Hello, welcome to our notes on simplifying trigonometric expressions. In this video, we're going to learn some different strategies, actually just take notes on them. So for your strategies, remember, you may use any or all of these strategies in a single problem. Don't limit yourself, and sometimes you have to try multiple ones. You most likely will have to apply your fraction skills, and the goal is to get a single expression if possible. So let's take a look at the strategies we have. You can use reciprocal and Pythagorean identities. That's like using the fact that sine equals 1 over cosecant, or sine squared plus cosine squared equals 1. You can factor, and then sometimes after factoring you use the Pythagorean identities. You can find a common denominator in your fractions. You can split one fraction into two, and you can multiply by 1. So let's start out and using reciprocal and Pythagorean identities. So we will use this problem here. First thing I do when I see division is I always rewrite it sideways. So I'm going to use some of my identities. Tan x is equivalent to sine x over cosine x, which is divided by 1 over cosine x, as that is the secant. In order to divide, you multiply by the reciprocal. So I have sine x over cosine x times cosine x over 1. These cancel, and I'm left with sine x, a single expression that's very nice. So let's look at example number 2, which goes along with the factor strategy. I always look for a GCF first. I see that cosine x is the GCF. Pull it out, I'm left with 1 minus sine squared x. Identify that as a Pythag identity. Off on the side, sine squared plus cosine squared equals 1. Therefore, cosine squared equals 1 minus sine squared. This becomes cosine x times cosine squared x. Multiply those, and I now have 3 cosine x's, so cosine cubed x. Continuing down to finding a common denominator. When finding a common denominator, I don't mean to see a denominator in this problem. That must mean I had to apply a different strategy. So if you go back up for a moment, you can see we're going to first use the reciprocal and Pythagorean identities. We're going to rearrange this, then we'll find a common denominator. So this will be sine x plus cosine x, and then we have cosine x over sine x. Therefore, I have sine x plus cosine squared x multiplying over sine x. I want a common denominator, which will be sine x. I'll multiply this side by sine x over sine x, and this side I'll multiply by 1. My common denominator is now, as I said, sine x. In my numerator, I'm going to get sine squared x plus cosine squared x. That I recognize as a Pythagorean identity, which is 1 over sine x, and then I get cosecant x. That would be simplified. Cosecant x is better than having a sine x in the denominator. Okay. So then we're going to split one fraction into 2. Do you notice how this is one fraction? We're going to actually split it into 2 fractions. You can only do this when there's a plus or minus in the numerator. Does not apply when there's a plus or minus in the denominator. So I can spread this apart to secant x over secant x minus cosine x over secant x. This becomes a 1. This looks more confusing, so I'm going to rewrite it as cosine x divided by secant x. So I have 1 minus cosine x divided by, what's secant x? That's 1 over cosine x. How do you divide? You multiply by the reciprocal. So I'm going to multiply by cosine x, which gives me 1 minus cosine squared x. That looks like a Pythag identity. Sine squared plus cosine squared equals 1. Getting 1 minus cosine squared means this equals sine squared x. Done. The final strategy is to multiply by 1. So you see that we have cosine x minus 1 over sine x. Multiplying by 1 just means multiply the numerator and the denominator by the same thing. So what I'm going to do is multiply it by sine x on both the numerator and the denominator. Okay? Sine x. So then I could get sine x times cosine x minus 1 over sine squared x. I am now going to take this sine squared x and use the Pythagorean identity. Sine squared plus cosine squared equals 1. So therefore, sine squared equals 1 minus cosine squared. So my numerator is sine x times cosine x minus 1 over 1 minus cosine squared x. Why do I care? Because this is now looks like it's factorable. So my numerator is going to remain the same. And my denominator becomes 1 minus cosine x, 1 plus cosine x. These look pretty similar, these two diagonals, except the signs are switched. If I make this a negative sign, it'll switch both the signs inside the parentheses, making these two identical. So they cancel, and I get negative sine x over 1 plus cosine x. Maybe it doesn't look nicer, maybe it doesn't. Which brings us to the final part of our notes. So simplifying versus verifying. Verify is you get what they want. Simplify, you want to make the expression as simple as possible. What we just did was simplifying. What you look for when verifying is they give you an equation like sine squared x equals something over here. And what you need to do is make these two expressions show that they are identical. So what are the keys to doing that? Well, the keys to verifying are work with one side of the equation only. I usually work with the more complicated side. And use the simplifying strategies to get their desired outcome. We actually start our unit with verifying, and then we work to simplifying. In verifying, you usually end up identifying how they want it to look when you simplify. So that is the end of our notes for today.